In this question, we're told that kerosene, we're given the density of that, flows through a venturi, and it's pictured here. And we're asked to find the velocity in the approach section, so that's upstream. So we can see from the picture that the velocity in the throat is 10 meters per second, and also that the pressure differential is 20 kilopascals. So we don't need to work that out from this manometer. We've just been told it. Okay, so how do we go about solving this? So again, we start with Bernoulli's. Okay, so we write it out between 1 and 2. So 1 being the upstream location and 2 being at the throat. Okay, so we write that out. We can see that this is horizontal. So therefore Z1 is equal to Z2, and these two terms cancel. So now we're left with this. So we can rearrange this for C1, which is what we're trying to find. Okay, so we're taking this equation, so we combine the pressure, divide through by the density, and then bring C2 onto one side and square root. So we get this in terms of C1, which is obviously what we're trying to find. So we just rearrange Bernoulli's here. So this is what we had from the previous slide. So now we can work this out because we know what the pressure difference is, and we also know what the velocity in the throat is, C2. But one thing just to bear in mind is we're told this pressure difference, and this pressure difference is given as a positive value. Okay. Now in our equation we've got P2 minus P1. Now we know from Bernoulli's that as fluid flows through this section, at the inlet it will have a higher static pressure and a lower dynamic pressure, and at the throat it will have a higher dynamic pressure and therefore a lower static pressure. So if the pressure at 2 is lower than if the static pressure at 2 is lower than the static pressure at 1, then what this means is that P1 minus P2 must be equal to 20 kilopascals, because this is positive. However, we've got it written here as P2 minus P1. Therefore, as I just said, if P1 minus P2 is positive, then P2 minus P1 is negative. So when we put the pressure into here, we need to make sure that we put a minus sign in front of it. Okay, and just to kind of elaborate on that, example I use is, if you hear someone say on the news that, oh, the pound has gone up against the dollar by 10%, think okay. But they also say, oh, the pound's gone down against the dollar by 10%. But they wouldn't say, oh, the pound has gone up against the dollar by minus 10%. So the difference is normally always expressed as a positive value, 10%, but the context tells you whether it's gone up or down. So it's the same here. So we've been told that the pressure difference is 20 kilopascals, which is a positive quantity, but we need to then ourselves determine the context from that, and the context is that P2 is less than P1, therefore if we have P2 minus P1, this needs to be negative. Okay, and if you do that, then you should end up with an answer of 7.13 meters per second for C1. And actually you'll find this, if you put a positive value in, if you did put a positive value in here by mistake, then you end up with an answer around 12 meters per second, I think, something like that. So if this is at 12 meters per second, you must know that you've done something wrong, because what you're saying is the fluid is getting slower as it's going through this contraction, and we know from continuity that that can't be right. The fluid must speed up as it goes through this section. So hopefully you would have realised you made a mistake if you got fluid velocity higher than 10 meters per second.